You're probably wondering why I'm standing here in the middle of a field. Well, it's because this month's Science Saturday topic is
Field Trip Science!
So the field trips we're gonna take this month for Science Saturdays are Charleston Falls to study weathering and erosion, to the pool to study pool water chemistry with Knickerbocker Pools and Spas, and to your own backyard. We're gonna teach you more about how to respect and inspect the insects that are all around you. Also, don't forget, after the show, we're gonna give you a link for a Zoom call where we're gonna talk more about how ants and networking are related and follow up with those lab notes that we have for you for this month. So enjoy the show and give us your comments.
Science Saturday, why it's a lovely day to try some science and say, why does it happen that way? Ask some questions, get some answers, see some science, hear some laughter. You might even find yourself thinking and learning and laughing. Oh, Science Saturday, why it's a lovely day to try some science and say, why does it happen that way? Why does it happen that way? Why does it happen that way? What are we studying for science today?
So here we are at Charleston Falls. You could come and visit Charleston Falls Preserve yourselves, right here in Miami County. Behind me is a stream. It's pretty dry right now because we're in a dry season. We're not getting much rain. But you might be asking yourself, how are they created? That is science. Erosion creates a stream. There might be a stream of water that starts, and it's going to follow the path of cracks or around boulders. This is why many streams aren't just straight paths. They wind and they have curves. It's because the water that is flowing is following those cracks in the ground. Over time, those cracks create fissures, and they get bigger and bigger and bigger and bigger and wider and wider and wider and wider until you have large rivers and streams. Erosion. I'm situated at the lower falls viewing area, and above me is the upper falls viewing area. Now typically, these falls, maybe in the springtime or after a large rain, will be coming down with much greater velocity and volume of water. But we're in a dry season, we're not getting much rain here this summer, and so the only thing falling is the little trickle you hear right behind me. When we think about weathering and erosion, we think about how they work together in combination with one another. Waterfalls are a great way to see weathering and erosion working hand in hand together. You see, a waterfall typically is formed because there's hard rock layers and there's soft rock layers. And when the water starts streaming down, it starts eroding away the soft rock. And so you get these concave structures where the water can jet out over and create a waterfall. This is science! Weathering and erosion. You can also see a cave. Caves, or solutional caves, are developed by weathering. That's right, it's science! You see, solutional weathering happens when the water starts seeping in through cracks in the ground, and again, the softer rocks, that sediment, starts to dissolve, and so then you see these openings. So if you look deep inside of this cave, it gets 0 sunlight. It's a cave. What makes it a cavern? Well, caverns specifically develop those stalactites and those stalagmites that form from the ceiling and from the bottom of the ground, and sometimes they touch and create columns. If we were to venture back into this cave, we could find some former stalactite formations on the top of the ceiling. It's science! Come check it out! Behind me is actually a man-made waterfall, not naturally made by weathering and erosion, but instead, this was made to help power a mill when it was first created. There is a 20-foot dam that is a part of the falls, and this is an 18-foot drop here on this fall. But it's another great location for you to come out and see a waterfall or hike some beautiful trails. Science! 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 Science!
Whoa! Well, hi, Dave and Nancy. Hi, it's Mr. Frank, and this is Science Saturdays. We're at the pool, and I'm here with Nancy and Dave. They are pool experts, and we're going to talk today all about pool chemistry, how you can keep your pool clean, and how you know when it's safe to swim.
The most important component of sanitizing your swimming pool is liquid chlorine. Liquid chlorine is something that we'll put in the swimming pool to kill bacteria and make it safe for your family and your kids to swim.
But let's go ahead and test the chlorine of this pool, see what that's like. I'm here with Madeline, and she's going to test for free chlorine in this pool water. So go ahead. So she's got to do a test kit. She scoops down, she gets some water, and she has to empty it out to a certain level. And then she puts 5 drops of this reagent in. And what the reagent does is it reacts with the chemicals in the water, and it turns a certain color. And you can see it's turning a very, very saturated yellow, which tells us that chlorine is 5 parts per million, which is a little bit high, but that's okay, and Dave can explain.
So when we test for chlorine readings, we're looking for chlorine readings between 2 and 3 parts per million. On a once-a-week basis, we're going to shock the pool with a little bit extra chlorine, which is going to raise it, and that's used to kill anything that could be sustaining life in that lower level of 2 to 3 parts per million.
And if I get in a pool that has 5 parts per million, am I at risk?
Absolutely not. Perfect sanitation level. It actually is going to be a better level for that time frame because there is absolutely nothing going to survive in that pool.
Okay, sometimes I get in a pool and I get like burny eyes or a sore throat. Is that the chlorine?
That is typically not the chlorine. That's going to be the pH level not being properly balanced in the swimming pool.
Okay, great. Well, let's talk about pH level next. Well, I'm here with Connor, and Connor's going to help us test the pH level of this pool. pH stands for power of hydrogen, but it's what we use to test the level of acidity in everything, including humans and pool water chemistry. All right, go ahead and take a sample there. Now what he's going to do is he's going to take a different reagent. So he's going to add 5 drops of this different reagent to the pH side. So now, as you can see here on the pH side, we're right in here at 7.5. And 7.5 is right where we want to be for our pH level. We want to be between 7.4 and 7.6. We just measured for pH, and Dave, why is pH at 7.4 to 7.6 range really important for pool water?
pH is really important for your pool water because of a few different things. One, if the water is too acidic or basic, it can affect your pool equipment. It can be harmful to your pool equipment. 2, we want our sanitizer to work effectively. And for a sanitizer to work effectively, our pH of our water needs to be different than the pH of our liquid chlorine. If the pH of the water is extremely high, the liquid chlorine can't do its job. And finally, pH of your skin and your eyes and things the water comes in contact with, if it's the same as the water, it's comfortable. If it's very far off from normal, that's when you typically get the red eyes and the burning eyes and that different feel in the water. It has nothing to do with the chlorine level for most people. It's usually the pH level.
So when the pH level is where it needs to be, then the chlorine does its job of sanitizing. Is that what you're saying?
Correct.
Okay, and so when it sanitizes, what the chlorine does, from a scientific chemical perspective, when you mix chlorine with water, you get hypochlorous acid, which sounds really terrible, acid, but it's a weak acid, and that acid keeps the balance of the pool. It breaks down the cell walls of a lot of the bacteria and viruses that are in the pool and eliminates them, so they can't get into your body and attach to you.
Makes your pool water safe to swim.
All right, so we just got done talking about pH and how it's really important to maintain pH. And that's a measure between a total acid and a total base, which is sometimes also called an alkaline.
Right.
But there's something about pool water chemistry called alkalinity. What's that?
Alkalinity is the water's ability to resist a change in pH. So it can start too high, especially with new water in this part of Ohio, and it can get too low. And we measure that also in parts per million. So there is a way to find a balance and try to get it stable.
What kind of things can interrupt the balance of that?
Pool water balance can get off by what we call heavy bather load, which is a lot of people swimming. Another variable is the weather.
You said you get a lot of phone calls.
We get a lot of phone calls because whatever was in the rain, the chlorine had to burn up the organic matter in the pool, and so people end up with a high pH and a low chlorine reading, and it makes the water a little cloudy. And then they say, what do I do? How do I get back to sparkling clear water?
Well, that's great. Thank you, Nancy, and we thank Dave for the use of his pool and his water chemistry knowledge. Can I jump in?
Swim. And now it's time to play Guess What Fultie's Thinking.
I'm thinking about something that has 6 to 10 million different species. You could find them in your home. It's kind of small or tiny. You can find it in your backyard, your playground. They might take over the world. That's right, I'm talking about insects. Insect science. Scientists that study insects are called entomologists. What is an insect? One is an insect. One is not. Do you know which is which? See, ants are a species of insect, but spiders are a species of arachnids. Let's take a look at their body parts. The ant has 3 body parts: the head, the thorax, and the abdomen. Our second clue we can find by looking at how many pairs of legs these specimens have. 3 pairs or 6 legs. Those are important qualities to classify an insect. I'm sure you've seen them plenty of times. Butterflies and bees, ants and termites, beetles and locusts. There are so many different kinds of insects, but they're going to have 3 main body parts and 3 pairs of legs.
And now, Fultie's going to take us through a new game called Benefits, Detriments, Benefits, Detriments, Benefits.
Insects have both benefits and detriments on Earth. I'm going to show you some pictures and I want you to decide where I should place them. Is it a benefit or a detriment? This looks like to me beetle shish kebabs. Does anybody want a beetle shish kebab? Beetles and other kinds of insects can be a good source of nutrition for you. We would call that a benefit. Let's take a look at another one. It looks like we've got some carpenter ants or some termites chewing up some wood. These insects can get inside your homes, buildings, and cause a lot of damage to the structure that holds up your house. That would be a detriment. Let's take a look at another one. On this picture, I have some locusts, and they are eating up some crops. For farmers, people who are relying on the crops that they plant, and they might not have the income coming in if they destroy enough of their crops. So, yep, that would be a detriment. Okay, let's take a look at another one. I have ants here, and these ants are crawling in the soil. So if their movement is helping to aerate the soil naturally, do you think that's a benefit or a detriment? I hope you're saying benefit. Yes, insects do have detriments to us, but they also have benefits. And so, next time you're out and you see an insect, you might think to yourself, they're not half so bad. I mean, decomposers, pollinators, good food source and nutrition, naturally aerating the soil. Those are some great things to think about the next time you see that ant. You can go on your own field trip and find insects just about anywhere. A great place would be a park or a playground somewhere close nearby. In fact, I'm here in Cox Arboretum Metro Park in Montgomery County, Ohio, where they have a butterfly house. And remember, butterflies, they're insects too. So right now it's closed, but come next spring, you should definitely come and look through that butterfly house for different kinds of butterfly species. And just take a look to see if you can see the butterflies in their different life cycles. Remember, they have the chrysalis stage. You might be able to find some of the chrysalises there, or the caterpillars. So make sure that you make this one of your field trip stops come spring.
And now for our final game. What tools do you need when you go out insect exploring? Or WTDYNWYGOIE? Or something like that.
So wherever you go, you can make a field trip out of insects. And I have a few items to help us on our journey for finding insects. You might need some binoculars, a magnifying glass, tweezers to carefully pick up your specimens, some sort of container. That container should have holes. And if you're going out at night, a handy dandy flashlight.
Thank you for joining us for this insect segment. And remember, insects are friends and food. Ouch.
We hope you enjoyed our show, Field Trip Science. And also, we hope that you found some great places to take a field trip of your own and see some science all around you. Stay tuned for more information on Facebook as we have it for the last show that will be upcoming for this season. Also, there should be a link to our Zoom call that's coming up right after this, so you don't want to miss it. Look for the link in the comments and go to our Zoom call now.
Science Saturday, why it's a lovely day to try some science and say, why does it happen that way? Ask some questions, get some answers, see some science, hear some laughter. You might even find yourself thinking and learning and laughing. Oh, Science Saturday, why it's a lovely day to try some science and say, why does it happen that way? Why does it happen that way? Why does it happen that way? What are we studying for science today?